So what we've got here is a ray box with a slit so that it makes a nice thin ray of light. And remember, when you draw these rays of light, you should always use a ruler and draw an arrow to show the direction of light moving. Now here we've got a plain mirror, just means a flat mirror, and we have the light coming in, it's hitting the mirror and it is reflecting off. And if we drew a normal line, which is the dotted line at 90 degrees to the surface, okay, you can see that the angle of incidence, the angle the light is coming in here, is pretty much equal to the line of the light coming out here. So now we're looking at this situation with the light on, simply so that I can show you the diagram that you would potentially draw in this situation. So if we take the light box away, move my keyboard so you can see what I've drawn. So I've simply drawn over the light rays, and like I said, you should have an arrow there to show the movement of light, and you should have the arrow coming out the other end. Now when you're asked to draw these diagrams in the questions, you must draw them, you don't have to use a protractor, you draw them by eye. It should be pretty easy to see that this angle here is the same as this angle, but you don't actually have to measure them. And in a lot of situations, the questions will not give you the diagrams to scale. It's not the easiest to see because the light isn't particularly strong, but let's see what we can do. So we've got the light coming in here, okay, and you can see that it comes in to the glass, all right, and if we draw again over that light ray, I have drawn around this block so that when I move this block, I'll be able to see it. And I'm also going to draw the line coming out. Then we will be able to see that the light came in here and came out there. So if we join those two up through there, see that the light appears to have bent in its journey through this glass block. And the reason for that is that the glass block is, well, it's not glass, it's acrylic. The block is more dense of a medium than air, so light is actually slowed down as it comes through it, and it is bent towards the normal lines. Okay, so if I draw a normal line through there, as the light comes in, again, you should always draw arrows. Light comes in, this angle here is significantly larger than this angle here, so it is bent towards the normal line. Okay, and when it goes back out again to the air, a less dense medium, the angle of incidence there is very small. When it comes out into air, this angle is much larger. Okay, and when you're asked to sketch these diagrams, you don't have to worry about the exact values, the exact differences. You do just have to make it clear that there is a difference. And you can see that if you bring it in with a greater angle here, the effect is more pronounced. So when I show you with, when it's hitting nearly straight on, the effect isn't that clear. But if we were to turn it and make that angle much steeper, you would see a much clearer bend in the light. So when it has a greater angle of incident, the refraction is much, much clearer. Now here what we've got is a semicircular block. You'll probably see it a bit better if I take the grating out of my ray box. So this semicircular block, what this means is that the light will hit the curved edge at approximately 90 degrees every single time. So no refraction actually happens going into this block. And it means it shows us a very interesting thing about total internal reflection. So when the light goes into that glass block, no refraction happens. But obviously when it comes out of the glass block, some refraction can happen. So you can see that the light is bending there because I am changing the angle that it is hitting that other flat side of the glass block. But the most interesting thing is, if we get it to a certain critical angle, if we get it to hit a steep angle, then what will happen is that we will start to get total internal reflection. So you can see that reflection only appears when we get after a certain point, and it's called the critical angle. If we bend it so that it's suddenly at that critical angle, total internal reflection, internal because it's reflecting just not off a mirror, but off a surface within an object, within a transparent object. We're also still getting a little bit of refraction coming off here. Now finally, this is just a little bit of an extra because we don't really have to do this until IGCSEs, but this is quite cool because this is our equilateral triangle block, and we should be able to get a rainbow appearing. I want to project it on my keyboard over there. There we go. The different colours present in white light are being refracted by different amounts. So blue light is being refracted the most and red light is being refracted the least. And therefore it's being separated. So this is happening because white light actually contains all the different colours of the visible spectrum. So this is how you get rainbows. Lots of refraction of light.